All right, we want to take a look at the derivative of a product. First of all, the derivative of the sum was the sum of the derivatives, and it would be really nice if that was the same here. But alas, it's not, because notice that we already know that the derivative of x squared is 2x. Right? The 2 comes down, you got an exponent of 1. But notice that x squared is equal to x times x. So if the derivative of this product was a product of derivatives, the derivative of that one is 1, and the derivative of this one is 1. And so certainly the derivative of x squared is not equal to 1 times 1. So we don't have the product of the derivatives is the derivative of the product. So we have something else. Okay. And I could derive it. Actually, let's just state it and we'll derive it in another video here. Here's the product rule. So if you've got the derivative of f of x times g of x with respect to x, that's the first function times the derivative of the second function plus the second function times the derivative of the first. First times derivative of the second plus second times the derivative of the first. This is what we call the product rule. Okay. In some ways, I look at this and say, well, it's like we had a rule that if you have a constant times a function, then the derivative is that constant times the derivative of the function. So almost to begin with, it's almost like f was behaving like a constant, because you just have that f there, and then you had the derivative of g. Likewise, in a way over here, it was almost like the g was just a constant being multiplied by f, because the derivative turned out to be just g times the derivative of f. So it's almost like you kind of treated each as a constant and then took the derivative of the other one. Anyway, this is the product rule. Let's do an example here or two. Here I've got f of x equals x squared times e to the x. What's the derivative? Well, the derivative is the first function times the derivative of the second. I'm going to write more steps down than I would normally write out, just because to begin with, I think it's good to see the steps. Later I'll take these derivatives on the fly, but here we go. We've got x squared times, so first times derivative of the second plus the second function times the derivative of the first function. Okay, and then let's do these derivatives on the inside here. I've got x squared. The derivative of e to the x is just e to the x plus e to the x times the derivative of x squared, which is just 2x. Okay. Now we've taken the derivative. Anything we do from here is just algebra, cosmetic work. You could leave it like this. You could rewrite it. Sometimes people say, oh, I noticed there's an e to the x inside there. So factor an e to the x out. You got x squared plus 2x. Anyway, so there's one example of the product rule. Let's try another one. We don't have that many functions we know how to take the derivative of at the moment, so finding examples there's going to be more than one way we can do these, because we have other options, but let's take a look. Here's another one. Let's say g of x is equal to x squared plus 5x, and then we're going to multiply that by the square root of x. Okay. G prime of x. Okay. Now, one of the things that we've got to learn how to do here, and that is to decide what derivative rule to use first. Because I look at this thing, and there's a lot of stuff in this function going on. There's a squared, there's a plus, there's a times 5, there's this product here, there's a square root. What do we do first? Well, If you were to plug in a value, let's say if I said, what's g of 1, right? I want to know what's the last calculation you would do in order to tell me what the value of g of 1 is, right? So you'd say g of 1 is equal to 1 squared plus 5 times 1 in parentheses and then the square root of 1, right? So what would you have to do? You got to figure out square root of 1 is 1. You got to say 1 squared. I'm just doing the order of operations here. 1 squared is 1 plus 5 times 1. So you multiply the 5 and 1 to get it 5. So I got 1 plus 5 is 6. And then I'd say 6 times 1 is 6. The last calculation I did was that times. This is a product, and so I use the product rule first when I'm taking this derivative. Okay, so this is a product of two functions. It's the last thing you would do when you plugged in an x value would be to multiply. So here we go. The derivative is the first function times the derivative of the second plus the second function times the derivative of the first. Okay. So that was a product, and now that product gave me two other derivatives, and I have to look at each one of those individually and see what I have to do. One of the things that I find is a problem for a lot of students is that they try to do too much at the same time. Apply one derivative rule at a time. Once you get more practiced at it, you might be able to see how to work a couple of them at the same time. But for the most part, you're doing one at a time. This is a product. I'd use the product rule. Okay. Now, within that product rule, I have to take the derivative of the square root of x. So I've got this x squared plus 5x still here, times the derivative of the square root of x. Well, I'm thinking of the square root of x as x to the half power. So the derivative is going to be 1/2 x to the negative a half power, right? Bring the exponent down and then subtract 1 from the exponent. So there's the derivative of the square root of x. And then I've got the square root of x here, and now I need the derivative of this thing. Well, this is a polynomial. It's a sum, right? If I plugged just looking at this function now, if I plugged a value in for x here and there, I'd multiply by 5, I'd square, and then I'd add. This is an addition problem, so the derivative of a sum is the sum of the two derivatives. I just need to take the derivative of this piece and then the derivative of that piece. Well, the derivative of the x squared is 2x, and then add on to that the derivative of 5x. Well, that's just 5. And so there we have the derivative. Again, anything beyond this point is just algebra. And you know, if you're doing a problem from the book and you're checking the answer in the back, you know, they may have done some algebra, and you've got to figure out if you can make your answer look like theirs. To me, the way you write an expression really should depend on what you're going to do with it next. Now, later in the quarter, we're going to have applications for these derivatives, and we're going to do things like we're going to know when is this equal to 0. So, you know, setting something equal to 0, you probably want to factor it. But at other times, there's other ways you want it written. So for right now, I don't really care how you write it, because all we're doing is just reporting it as an answer. So if you leave it like that, it's fine. If you see somehow that it might simplify nicely, then by all means, you know, you can do that. Let me point out that this problem could have been done differently, because I'm going to do the same function here. Because I could have just used a distributive property to begin with here. That is, I could have written this function. I have not taken the derivative yet, right? That was g and g prime. This is still g and g. I'm not changing any. I'm just going to distribute this in. So I've got x to the x squared times the square root of x plus 5x times the square root of x. And if I think of, you know, something like this, this is x to the half power times x to the 2 power. So this is actually x to the 2.5 power. Oops, not 5.2, 2.5. Likewise here, this is 5 times x to the 1.5 power. Right? And so I could take this derivative as 2.5 x to the 1.5 plus 5 times 1.5 times x to the 0.5. Okay. Now, this doesn't look like that immediately, but apparently there's stuff that combines and cancels out. If we try to simplify that, we should be able to get to this. Anyway, I'm gonna, this is like 7.5 x to the 1, x to the 0.5, and I got a 2.5 x to the 1.5, plus sign in between. Okay, whoops, oh man, this is a classic mistake here that I just made. G is equal to this. Right here it stopped being G. This is now G prime of x. This is a I made a mistake that I really, no, wait, don't, I just made it again. See, this is where I got to be really careful. G, where did this stop being G and start being the derivative? It was actually right here where I started taking the derivative. So that was G. This is now G prime of x. The thing is, we're going to distinguish between the function and its derivative. This is a brand new function. It's not that one. It's telling us the slopes of that one. Okay. Anyway, two different ways to do this problem. Actually, it'd be challenge you here to distribute this through, distribute that through, gather some like terms, and see if you actually get the same answer. You should.